Section 3.5 is on page 277, talks about derivatives of trig functions. This is something we established. If we're taking the limit as theta or x approaches 0 of the sine of x divided by x, that limit equals 1. Another limit that seems to come up every now and then, the limit as theta approaches 0 of the sine of theta, of the cosine of theta minus 1 divided by theta, that's also 0. And we could establish that by picking points if there's a need, and you could see what that is. Now this comes up a lot more. This we've already seen. Well, we start with, we want to take a derivative of trig functions. Let's say we want to take derivative of a sine of x. We'll say f prime of x is the limit as h approaches 0, the sine of x plus h, that's f of x plus h, minus sine of x, which is f of x, all over h. Well, we know the function, we know that sine of the sum is sine of the first cosine of the second plus sine of the second cosine of the first. Now if I get those two together and I split this up, I'll get the limit as h approaches 0. So if I combine those, the sine of x plus cosine of h minus sine of x all over h plus the sine of h cosine of x over h. And if I split those accordingly, if I factor a sine out of those of 2, and here, if I look at cosine of x times sine of h over h. Now, I am aware that based on the second piece, that's a 0. And this is, oops, color didn't register. And this is simply a 1, and it's right there. And I'm left with the cosine of x. So it turns out derivative of sine of x is cosine of x, and they're listed here. I suggest you memorize those three. So derivative of sine is cosine, derivative of secant, secant 10, derivative of tangent, secant squared. You memorize those. And the cofunctions, derivative of cosine associated with is a negative. If derivative of secant is secant tangent, derivative of cosecant is cosecant cotangent with a minus, and derivative of tangent is secant squared, so derivative of cotangent is cosecant squared with a negative. So the derivative of all the function with the c, the cofunctions, are all negative. So memorize the first three and you can derive the other three. Well, here we are. Find the derivative. Well, dy dx will be negative 3. Derivative of cosecant is cosecant of x cotan of x. And this is really 5x to the negative 1. So if you take a derivative of that, that becomes negative 5x to the negative 2. And again, derivative of cosecant is right there. So my answer would be now the rule of thumb. If you start the problem with a negative power, you could leave your answer with a negative power. But if you altered, if you took a positive power and made a negative power, you have to bring it back. That's the rule of thumb. And if I take the next problem, the derivative of y would be, well, that's a 1 minus, and this is the product rule. Derivative of the first times the second plus the first times derivative of sine we developed that was cosine. On a quiz or test, that's what I want, but for the homework we want to clean this up to match it with the back of the book. And in the next chapter you're going to have to simplify this anyway. So on a test, when I say differentiate, do not simplify, I just want the calculus. Here, this is the product rule, derivative of the first times the second plus the first, and derivative of tangent is secant squared of x. Here I have the quotient rule. So if I take a derivative, that will be over the bottom squared. Derivative of the top, derivative of tangent is secant squared of x times the denominator minus the top times derivative of the denominator is negative secant tangent. So that's because of that minus. Derivative of secant is secant of x tan of x. Again, that's all I would want on a test, especially the first test. And if you clean that up a bit, you could say that is secant squared of x minus secant cubed of x plus secant of x tan squared of x over 1 minus secant of x squared. And I suppose they all have a secant. You could factor a secant out, and you'll have a secant of x minus secant squared of x plus tan squared of x. And again, this is not really more simplified, but most likely that's how they write it in the back of the book. All right. So this is not a long section. Kind of fun, kind of, sort of. And the last problem, well, if I want to take a derivative, that's also the product rule. That's derivative of the first times the second plus the first, and derivative of the second, that's 0. That's derivative of secant is secant tangent. Derivative of cosecant is cosecant of x cotan of x with a minus. And that's pretty much it. You could say that's negative the sine of x minus. Now, cosecant is 1 over sine. So negative sine times 1 over sine is a negative 1. Distributing this. Oh. I know that. Oh no. This everything stays the same. It's a minus, not a plus. Cosine of x, cosecant of x, cotan of x. And the reason that doesn't simplify at all, because that's 1 over sine, and that's cosine over sine. So cosine doesn't cancel out. All right. The rest is just repetition of it. Find an equation of a tangent line. That's something that's never going to get old. We're going to do this non-stop. To find the point, I take pi over 2, and we know cosecant is 1 over sine. Sine of pi over 2 is 1, so there it is. And to find, so it's y minus y1 equal m into x minus x1. And if I take a derivative, that is negative cosecant of x cotan of x, evaluated at pi over 2, that is negative one times 0, so that's 0. Put a 0 there, and there it is. So the equation is y equal 1. Similarly, if I get to this problem, I'm looking, so every time you're stuck on a trig, you have one of two triangles to draw. There you go. So when x equal pi over 4, which is 45 degrees, Secant is radical 2 over 1, so I have y minus y1 equal m into x minus x1. That will be my answer if I could only just find the slope of the line. And since it's a tangent line, well, the slope of the tangent, derivative of secant is secant of x tan of x. Evaluated at x equal pi over 4. Well, here it is. Secant is the hypotenuse over the adjacent, and tangent is the opposite over the adjacent. And there it is. That's my answer. So again, this section runs really fairly quickly. It's not that long. And what about this point? Well, pi over 4, cotan of pi over 4 is also 1. So y minus y1 equal m into x minus x1. Well, I know the derivative, f prime would be negative 5 derivative of tangent secant squared cosecant squared of x. So that is negative 5 times this. Again, if I look at the triangle, cosecant is the hypotenuse over the opposite, so that's radical 2. And when you square it, you get a 2, so that's negative 10. And there's my answer. Alright. What if I want to find two derivatives? Well, that's busy work. Not hard, just busy work though. So I'll do this slowly. Y prime equal derivative of the first times the second minus derivative of the first of the second times the first. That's all I want on the test or quiz, but then again, well, I'm sorry, that's one derivative. We need another. So this is cosine plus sine of x. Now, once you name the Chern rule, which is next class meeting, then you could write those in a simpler form. What do you think those are right now? Cosine squared plus sine squared, isn't that a 1? And what is the second derivative with respect to x? Derivative of a constant is 0. All right. That's problem. Really a short section. I would like to prove that the derivative of secant is secant tangent. They say use quotient or product rule. Well, that's the derivative. Isn't that 1 over the cosine of x? So that is quotient rule over the denominator squared, derivative of the top times the bottom, minus the top derivative of the bottom is negative the sine of x. So that is 0. Negative times a negative is a positive. And I could say that that is sine of x over cosine of x, cosine of x. And sine over cosine is the tangent, and 1 over cosine is the secant. Or you could simply write it secant of x, tan of x, because multiplication is commutative, and there it is. And that's pretty much it for this section. So again, I'm cutting the homework down to roughly about 10 problems per section, 10 to 12. Just don't want you to do busy work.